This is about take 6 on this first problem. All kinds of technical difficulties and loudness difficulties, things like that. Okay, I'm going to do proofs 14 through 19. This could be a very long video because I have to keep starting and stopping and starting over, but also because there's a lot of complicated things that we're going to do. So we are given that we have parallelogram ABCD and that EF is congruent to HG. So those are the two things we're given. We are supposed to prove that AF is congruent to CG. So let's mark what we're supposed to prove. AF, CG. And we are given that EF, so mark your diagrams in first, EF is congruent to HG. We want to prove this little part of this triangle. So what we're going to try to do is we have two triangles. We're going to try to prove that the two triangles are congruent. Let me color in the two triangles. These are the two triangles. If we prove that these two triangles are congruent, then we know that all their parts are congruent, so CG will in fact be congruent to AF. So we need to figure out how to prove this is true. Okay, so we need to get, when we prove triangles are congruent, we're going to get side, angle, side. We could do side, side, side. We could do angle, side, angle, and we could do angle, angle, side. Those are the four without a right triangle. So let's see if we can get some more parts. All we have so far are one little side. So let's see what we can do. If we have a parallelogram, we have all kinds of things we know about the parallelogram. We know that BC is going to be congruent to AD. We're going to know BA is congruent to CD. And we're also going to know that the sides are parallel. If the sides are parallel, then this whole segment from B to H is going to be parallel to E to D because H is on the same line and E is on the same line. So I'm going to do that and I'll tell you the reason why. We're going to say that BH is parallel to ED. And that is because opposite sides of a parallelogram are parallel. Alrighty? The reason I'm going to do that is if you have two parallel lines, or parallel lines, they have to be two, cut by a transversal, so let's cut these guys by a transversal, then we know that the alternate interior angles are going to be congruent. So saying that, we can mark, let me get some bright color because it's kind of small. We can say that this angle and this angle, the first one's on top of the transversal, and this angle are congruent. It's kind of hard to see that sometimes. With the transversals, you have to almost extend your lines out to be able to see it, and extend this a little bit, and do the same down here. Extend this and extend this, and you can kind of see we have alternate interior angles. So it'd be like this and this. It's tricky to see. So let's write that in to our proof. So we're going to say angle BFAE is congruent to angle CHG, and this is by alternate interior angles. Okay, so now we have a side and an angle. We need to get ourselves another side somehow, or another angle. So we also know in parallelograms that the opposite angles in a parallelogram are congruent. So I can say that this angle right here is congruent to this angle. All right, so let's just say that angle BCD is congruent to angle BFBAD. And the reason for that is opposite sides in opposite angles in a parallelogram are congruent. All right, you're saying that's not even in the triangle. How's that going to help us? Well, because we know that this angle is congruent to this angle, we know that their supplements are going to be congruent. So we can say that angle EFA is congruent to angle HCG. All right, so that one would be supplements of congruent angles are congruent. All right, we're almost there. So now we can say, let me just mark this up in another color. We can say that this angle is congruent to this angle because they're both supplements of equal angles. So now if we look at it, let's see if we have all our parts. So we have a side, an angle, and an angle. And down here we have a side and an angle and an angle. So that we can say that the two triangles are congruent. So we can say, I'm going to run out of room, I guess. Let's just slide this down. So we can say that triangle FAE is congruent to triangle GCH by angle, angle, side. And then finally we can do our last step and say AF is congruent to CG by CPCTC. Alrighty, so the little tricky part I think for this one, first you have to recognize you have to get these two triangles congruent so you can get parts congruent. Tricky things is seeing this angle right here congruent to this angle by alternate interior angles, and also knowing that supplements of congruent angles are supplementary. You really have to work this, that you're given all this information, and try to work it out. One down, next one, 15. We are given, I'm just going to write the given right in here. Oh, we're given a lot again. We're given parallelogram ABCD, and we're also given that B is the midpoint of AE. And that would be given. Okay, what are we going to prove? Let's figure that out. We're going to prove that EF is congruent to FD. So let's mark that in there. EF is congruent to FD. That's what we're trying to prove. So let's go back to our given and see if we can mark our diagrams. It's telling us that B is the midpoint of AE. So that tells us that this is going to be congruent to this. So we can't just go from here to doing that. We have to write that down. So we have to say EB is congruent to BA. And the reason we say those are congruent is by midpoint. Let's just do midpoint divides a segment into two equal parts. All right, so we got that. We still have to figure out where we're going with this one. I didn't come up with the plan yet, but we're trying to get EF. It doesn't look like we're going to get two congruent triangles, but maybe it does. We do have this triangle and this triangle that could possibly be congruent. And the blue does lie in each of those triangles, so I'm thinking that might be the way that we go. All right, what else can we do? Well, if we go with that plan, because we don't have any other plan, let's prove that those two triangles are congruent. Because if we get them congruent, then we can say that their parts are congruent, and that's what we're really trying to do. So I'm going to take and just mark these up. We're going to try to get these two triangles congruent. So all we have so far is nothing. So let's see if we can do something out of this. All right. I can see one thing we can do. We can say angle EFB is congruent to angle CFD. And the reason? Why can we say that this angle is congruent to this angle? Anybody out there? Then we at least have one part. So that would be vertical angles are congruent. All right, so that's a little bit of something. All right, I see something else. We didn't use this information at all. But if we have that ABCD is a parallelogram, we know that the opposite sides are going to be congruent. So we can say AB is congruent to CD. So you have to use information up here to do the proof. And the reason for that would be opposite sides of parallelogram are congruent. All right, so we're making it. Look, now we have an angle and we have a side and an angle and a side. We just need a little bit more information. So here we go. I see another piece of information. What do we know about parallelograms? Well, we know that opposite angles are congruent. Does that even help us at all? Let's see. That might not even help us at all. AB is congruent to CD. We already did that one. Hold on. We have to pick. There's things that you can say that aren't helpful, and I would suggest you put them in anyway. Like if you say angle A is congruent to angle D, at least I know that you're thinking a little bit. But that doesn't really help us in this proof, so I'm not going to be thinking about that one yet. Let's see. What else can we say? BC is parallel to AD. All right, we can say that. We can say BC, and this is part of this great parallelogram stuff we have. BC is parallel to AD. And the reason for that is opposite sides of a parallelogram are parallel. All right, so let me mark that in. Now, when you're doing that, you want to think, okay, if opposite sides are parallel, why do I even care? Well, the reason that you care is so that you can find angles cut by a transversal somewhere. So let's see if we can find any. Let's see, EBF. EBF is congruent to FCD. Okay, so if we have this one parallel to this one, I'm just trying to think. I think actually we don't want that one. I think we want to say, I mean, not that one was wrong, but if we say that BA is parallel to CD, we get a little bit more mileage out of it. So we're going to say those two guys are parallel. It's getting messy here. So then we can say if these are parallel, and this transversal cuts it, then we can say angle EBF, this one right here, EBF is congruent to FCD right here. All right, because this is the transversal cutting parallel lines, and these are alternate interior angles. So we're going to say angle EBF is congruent to angle FCD, forgot my angle, and that would be alternate interior angles. Sometimes you make a mistake and you have to go back and fix it. I do that all the time. Sometimes you can't see it right away, so don't panic. Okay, so now let's see if we have all our parts. So we have an angle, and I can't even tell anymore, but a side, and we have an angle, and a side. So we haven't really said that CD is congruent to EB yet. I think it'd be easier if you guys were here to do this. All right, so far we've said that this is congruent to this, but this is congruent to this, therefore this has to be congruent to that, and that's by substitution. So we can say EB is congruent to CD, and that's by substitution. And then we can say the triangles are congruent because we have angle, angle, side. So we're going to do that real quick. We're going to say triangle BEF is congruent to triangle CDF, and that is by angle, angle, side. And then finally we did that, so we can say EF is congruent to FD because they're in this triangle. So we would say CPCTC. Okay, a little challenging. The parallel line part I think is kind of hard, seeing where the transversal and seeing where you get alternate interior angles, but it's the best way to get angles when you're trying to prove two triangles are congruent. Okay, hopefully I can make it through all these problems without wearing us out. All right, 16, we're given different things. We're given rectangle. So that gives us different things to work on. So we're given rectangle ABC, D, and we're given another part. This one's a little bit easier. We're getting M is the midpoint of BC. Okay, that's given. So M is the midpoint, so let's just write what we know here. If M is the midpoint of BC, mine's not perfectly straight, we can say that BM, I didn't even write down I just know that the midpoint, I'm just writing this, I didn't even write down what you're supposed to prove yet. So midpoint divides into two equal or congruent segments. All right, so we have that. We're trying to prove that AMD is isosceles. So let's mark that in, what that means with our blue. It means that this is congruent to this. Hold on, I gotta extend my time here. Wasted too much time on the practice ones. Okay, so that's what we're trying to get. So do you see what we have to do here? How about proving two triangles are congruent? Because if we can prove that this triangle is congruent to this triangle, then the parts are going to be congruent by CP/CTC. Now, what do we have? Let's think about what we are given. We're given a rectangle. So if we have a rectangle, we know that this is a right angle and we know that this is a right angle. So we can say angle B and angle C are right angles, and that's just the definition of a rectangle. Okay, write whatever you can over here. I'm more looking at the statements. I mean, the reasons have to back it up, but the statements have to be true. So, and then we can say angle B is congruent to angle C because right angles are congruent, right? Right angles are congruent. All right, so now we're looking, we have a side and an angle. This one's fairly straightforward. We can say BA is congruent to CD because opposite sides in a rectangle or a parallelogram are congruent. All right, we got that. So look at this. This one's working out pretty easily here for us. All right, now the two triangles are congruent. So we're going to say triangle BMA. MA is congruent to triangle CMA by, that would be side angle side. Then we can say AM, I'm going to go back up and show you. AM is congruent to MD, and that would be by CP/CTC. And finally, we can say triangle AMD is isosceles if two sides of a triangle are congruent, then isosceles. All right, let's just go up and show you what I did here. So we proved that these two triangles, this guy and this guy, are congruent by side, angle, side. We're given, this is because of the midpoint, this is because opposite sides in a rectangle are congruent. These are right angles because it's a rectangle. So right angles are congruent. The triangles are congruent. So if the triangles are congruent, then these are congruent. And if these are congruent, then this triangle is isosceles. That was a pretty straightforward one. If you get this one, it's going to help you to be able to get other proofs. That didn't have the parallel lines with the alternate interior angles, which made it easier. Okay, we have two more to do. Hang in there. I'm trying to hang in there. All right, for this one, 17, we're given a rhombus this time. So you have to know the properties of the rhombuses and rectangles, parallelograms, trapezoids. Okay, this is given, and that is all, yeah. So we have to prove that triangle ASC is isosceles. So to prove ASC is isosceles, what we basically want to prove is that if it's isosceles, then this is going to have to equal to this. All right, that's what we're trying to get to. We have a lot of, this looks a little bit complicated, trying to think it through. If I gave you the plan, it would probably be easier. So this one's slightly tricky. What we want to do is prove that this triangle right here is congruent to this triangle. Almost all of these you have to prove triangles are congruent. Use CP/CTC to get to whatever you're trying to prove. Okay, so we want to get these guys are equal. Okay, another thing that you might have thought is maybe get these triangles at the tops congruent, but we don't have enough information. We don't have really much information yet at all. I mean, we know the sides are all congruent, so that's something. So we might use that. So let's think about what we know about a rhombus. If we have a rhombus, the things that we know, I'll just mark these in this purple. We know that all the sides are the same, right? We know that. We also know that this forms a right angle. We know that. We know that the diagonals bisect each other, but I don't think that's going to help us any. We know that the opposite angles are not congruent, but the opposite angles are congruent, yeah. And I think that's about it. So let's just think this through together. So we have the rhombus. The first thing I would think is if we're going to prove these two little triangles are congruent right here and here, let's start with getting these angles. So we can say that angle AS, I can't read my letter anymore, R is and let's just say and angle SRC are right angles. I mean, I could have said maybe I shouldn't have skipped a step. Let's go back, sorry. Let's say that AC is perpendicular to BD. And we could say diagonals form perpendicular. Or we'll just say are perpendicular. Okay, then we can say angle SRA and angle SRC are right angles. Perpendicular lines form right angles. This is a lot of work just to say. Step 4, angle SRA, SRA is congruent to angle SRC, and that's right angles are equal, or are congruent. So we can mark that in. Let's just do it something brighter. Orange is nice and bright. So we have this one is congruent to this. That's all we have so far. Yikes, oh, I see one. One is popping out at me. It's like a little scavenger hunt. We can say that RS is congruent to RS. And why can we say that? Because of the reflexive property. So you just say reflexive. So let's mark that in. So we got that right here. So we have a side angle. Got it. Okay. So the next thing we can say, remember we talked about diagonals bisect each other? So we can say AR is congruent to RC because diagonals in a rhombus bisect each other. So let's get out our orange crayon again, and we can say that this one is congruent to this one. So now we can say those two little triangles are congruent by side, angle, side. So here we go. Let's just say that. Yay. Oh no, yeah. So we can say well, let's just jump to the triangles. Triangles ASR are congruent to triangle CSR, and that would be by side, angle, side. And we're proving they're isosceles, so we can say that AS is congruent to SC, and that would be by CP/CTC. And then finally, we can say that triangle ASC is isosceles. The same reason as we did the end of the last one is two sides congruent than isosceles. All right, that one wasn't too bad. You just have to pick, basically you're going to have to pick which two triangles you're going to have to make congruent to get what you want. And then you have to go out and figure out how, given this kind of information right here, gives you tons of information. And you have to pick which information you want to know. You have to know what's special about a rhombus or rectangle, etc., and then mark it in. All right, two more. We can do this. Whoops, I lost my whiteboard here. So we're on to 18. 18, you're given rectangle, A, B, C, D. So tons of information. Sides are the same. Sides are parallel. Opposite angles are congruent. All of them are 90-degree angles. The diagonals bisect each other. Lots of information. So that's our given. And we're also given a special piece of information that BE is congruent to CE. BE, let's mark that in. BE, CE. So basically, I mean, it's hard to mark in when it's let's just do a different color. So we're going to say BE, CE are congruent. All right, just mark that. If I put the slashes anywhere, it's going to look like I'm comparing two different things. So these are congruent. Okay, that's a ton of information in itself, because if they're congruent, we know it's an isosceles triangle. We also know that these base angles would be the same. I'm not saying we're going to use all that, but that's kind of some of the information we can get from this first little piece of information. Plus, of course, with the rectangle, we could say this is congruent to this, and these sides are congruent to these sides, etc., etc., etc. So we'll save that for what we need. Let's just write down our given here, our prove. So we are to prove that AF is congruent to DG. AF, DG. So do you see the two triangles that we're going to need to get? Just think. You have to try to get two triangles. I'm thinking, I haven't finished thinking it through yet, but I'm thinking we're going to try to get this triangle somehow or other congruent to this triangle. All right, let's go for it. All right. So we already have one part. We have this guy is congruent to, no, that's what we're trying to prove, right? AF. Never mind. That's what we're trying to prove. We are given BE. We're given these two parts. Ugh, I don't know if that helps us any. Oh, yeah, it does. Okay. So here we go. We're given rectangles. So if we're trying to get the orange triangles congruent, we can say that this side is congruent to this side. So we can say AB is congruent to CD. And that's opposite sides of rectangle are congruent. All right, so we already have side. Now we've got to get something else. We have to get angles and those kind of things. How about this? Angle A and angle D are right angles. And we could say all angles in a rectangle are right angles. And then we would say angle A is congruent to angle D, and we'd say right angles are congruent. Okay, so let's mark that in. Look how good we're doing. We have that and we have that. So we need to get another angle, another side. I don't see how we're going to get another side, so let's go with another angle. Now, you have to use this information somehow or other, and here's how we're going to use it. We're going to say that this angle and this angle are congruent. So let's just put that in. Let me just put another slash there. So we would say angle ECB is congruent to angle EBC. And base angles of an isosceles triangle are congruent. So I have to put isosceles are congruent. So, okay, how does that help us? Well, if we know that these two, we know that FBC and ABF are complementary because they add up to 90 degrees, we know that complements of congruent angles are congruent. So we can say angle FBA is congruent to angle GCD because complements, because they're both going to add up to 90 of congruent angles are congruent. I did this a different way the first time I did this. I did alternate interior angles are congruent. So that's an interesting way to do it too. I said this is just another way to do it. When you do proofs, there's going to be more than one way to do them sometimes. Since I said that these two are parallel, so I could say this one is congruent to this one, and then I could say that this one here is congruent to this one as well, because they're alternate interior angles, and if this is congruent to this and this is congruent to this, then this is congruent to this. So wow, more than one way to do this guy. All right, so let's just stick with the way I did it. So we'll make this one congruent and this guy congruent. 4, okay. So now we have side, we have the bad one. We have angle, yeah, we have, never mind, we're good. Angle, side, angle. So let's just move up here. So we can say triangle ABF is congruent to triangle DGC. And our reason for that, I'm just going to put below it since we don't have room, is angle, side, angle. So we'll put that 7. And what are we trying to prove? The parts are congruent, so we can say AF is congruent to GD or DG, and that's by CP, CTC. All right, so you can see there's two different ways. I did the one where these are, but since they add up to 90 degrees, they're complementary. And complementary, if you're equal complements of congruent angles are congruent. Or you could do these lines are parallel, and you could do alternate interior angles and then do substitution. All right, one more. We can do it. 19. All right, you are given ABCD is a parallelogram. So there's my crazy parallelogram, that's given. And we're given, oh, this one's different. AD is greater than DC. AD, so I'm going to do my silly thing that I do. AD, DC. Okay, there you go. Kind of silly, but that's so you know AD is greater than CD. Yeah, it's a parallelogram too, so we know all the things that are true about parallelogram. Opposite sides are going to be congruent and parallel. Opposite angles are going to be congruent. And we're going to be able to get like alternate interior angles and all those kind of things. So let's see what we're trying to get. We're trying to prove. So we are trying to prove, what are we trying to prove? The measure of angle BAC is greater than the measure of DAC. BAC, DAC, BAC. So we're trying to prove that this one here is greater than this one. All right, let's see how we do this guy. All right, so we have our proving thing. We can say the measure of BAC is congruent to ACD. All right, so we can say that these two guys are congruent. These two guys are congruent because they're alternate. If these two lines are parallel, I guess we should say that. Let's say that BC is parallel to AD, and that would be opposite sides of a parallelogram are congruent, or parallel. There we go. Parallel, go this way, wrong way. Okay, then we can say angle BAC is congruent to angle ACD. And that would be alternate interior angles. This is a pretty short proof. All right, so if the other thing we can say is angle because this side is bigger, this angle is going to be bigger. So we could say angle ACD is greater than this little guy down here. Angle CAD, and the reason why is larger side, opposite, larger angle. So now we're just down to plain old simple substitution. So we have this guy here is bigger than this guy. What are we trying to prove here? BAC. And we have that this guy is, this guy right here, we'll call him 1, is the same as 2 because they're congruent. Therefore, BAC, that's 2, DAC, and we'll call him 3. All right, 3. So here we go. Here's our transitive property. If 1 is greater than 3, hold on a second, I've got to extend again. If 1 is greater than 3 and 1 is the same as 2, then 2 has to be greater than 3. And we proved our point. It's basically substitution or transitive. So we would say, these are measures, I guess we would call these. Yeah, when you're comparing, when you're doing the, when you're comparing greater or less than, you need to put the measure sign in front of them. So then we'd say the measure of angle BAC is greater than the measure of angle DAC, and we would just call that by substitution. Okay, so did you get that? Because this side is greater than this side, this angle is greater than this angle. And because of alternate interior angles, these two guys are the same. So this guy is smaller than him, so he'll also be smaller than him by substitution. All right, somehow or other we got through all those. I wish I had more time to do these every week so you get some idea of proofs. They're getting more complicated, so it's a little bit harder. We might need to go back and do some easy proofs, and maybe you'll get it because you've been exposed to these harder proofs. All right, so one of these problems is on the midterm. That's all I'm going to say about that. All right, that's it. I'm going to send this out now.